Welcome all of you to Maths. This is my second video in trigonometry. Okay, this is going to be part 2. So please watch this video because I'm going to take up some little tough questions, that is introductory questions you can say actually, in trigonometry. So this is where you start understanding how sine, cos and tan is actually applied. So and how you find the values of sine, cos and tan. So this is the video for you who till today was very much doubtful about this topic, about this chapter. You will see that trigonometry is very simple once you see this video. Okay, another thing, this trigonometry will be again taken up as part 1, part 2, part 3. Please go sequentially, as I always tell you. I've been always telling you this in all my videos, that please watch the videos sequentially. One more thing that I want to tell all of you here, that watching a video is not a substitute for practice. Okay, this is what I have to tell you after my years of experience. Watching a video is never going to be a substitute or a replacement for your practice. These videos are just a guideline. They can give you the explanation. Please, after watching the videos, do the sums in your exercises, in your school textbook exercises. Do the sums, they are good enough, and then only and check your answers, see if you are coming correct or not, and that is what is going to give you confidence. If you just watch the video and you feel you are prepared the day before the exam, you will see that you are not being able to remember anything. So just it is a help for you where you can listen to the explanations and clarify your concepts. Okay, then let's see the sums. Okay, so let us see few sums where we use sine, cos and tan. Okay, so here we have a right angle triangle. We have a right angle triangle here which goes like this. Now the whole thing isn't a right angle triangle. There are two triangles here, practically here. This. So the figure is like this. This is A and then B and then C. Okay. Then here we have the D. Then this is 13. This is what is given to us. This is 5. This is 16. Okay. Now this is the triangle ABC and the 90 degree is here. Okay, here is the 90 degree. Now what are we asked in this sum? Sin B, we are asked to find sin B, then tan C. Now note the angles, okay. Sec square B minus tan square B. Sec square B minus tan square B. Okay, and we are also asked sin square C plus cos square C. Okay, sin square C plus cos square C. So this is what we are asked from this. I can see sine angle B here and angle C here. But if I am supposed to find sine B, I am not supposed to find it from the entire triangle but only from this much of it, only from this triangle I am supposed to find it. Okay, so if I am finding this, I am supposed to know this also, and I don't know one of the sides. So again I will be using Pythagoras theorem and I will be getting this. So let me take this as an x. 13 square, this is the hypotenuse, is equal to x square plus 5 square. That gives me 25 and 169. X square is a 169 minus 25, which is 144. This is a 144. X is a 12 by finding square root. So we know this is a 12 now. Now there are values they have asked for trigonometric ratios. They have asked even for tan C, for angle C. So in that case, we'll have to know all the sides of this triangle as well. Okay. So now we'll have to again find the value of this one. So let us find out for that too, and then we'll start with the sums all over. So here let me take this as a y. y square, remember this is the hypotenuse now, y square is equal to 144 plus 256, right? Okay, and 144 plus 256, I can see that is equal to clearly 200. Okay, sorry, 400, not 200. Okay, so y is a 20, so this value is a 20. So you can get sums like this where it is a combination of two triangles. What you have to note is where is the right angle, accordingly choose your hypotenuse. So here is the right angle, so this is the hypotenuse. If this is a 180 degree, this is a straight line, that means this is the another 90 degree, hence this is the another hypotenuse. So when if they ask C, we work on this triangle. When they ask B, we work on this triangle. So sine B is perpendicular by hypotenuse, 12 by 13. Tan C is 12 by 16. Okay, now remember this is a ratio, so we are supposed to cut this little bit, reduce it little bit. With a 4, if we reduce, we get a 3 by 4. Here we can't reduce. Okay, then comes sec square b minus tan square b, another place for confusion. Okay, sec square b minus tan square b. The moment this comes, you don't understand what to do. Let me first find sec b. Sec b is how much? Reciprocal of cos b. Okay, so cos b is a 5 by 13. So sec b is 13 by 5. Okay, and tan b is how much? Tan b is 12 by 5. Okay, so we have both the values ready. So we are going to substitute that over here now. Here we are going to substitute sec square, means this value gets squared, 169 by 25, 13 square by 5 square. Okay, and then we have plus, sorry, minus, this is a minus tan square b, that is a 144 by 25, which is how much? That is a 25. I can see it is 25 here, and 169 minus 144 will give me a 25. 25 by 25, which is equal to a 1. So the value here is a 1. Now this one, they want sin C and cos C now. So we should find sin and cos C. Sin C is a 12 by 20. I think, okay, we haven't found it. Sin C is a 12 by 20. So 12 by 20 square, that is 12 square, 20 square, plus cos C is a 16 by 20, 16 square and 20 square. So if I take 20 square LCM, you can even reduce it if you want, but if I am taking 20 square LCM, then 144 plus 256, that gives me a 400. Yes, that is 20 square is also 400, so it comes to a 1 again. Okay, so this is the answer for all the sums here. So do not mix up the values. Okay, so this is sin square C plus cos square C has also come to a 1. Sec square C minus tan square B has also come to a 1. Sec square B minus tan square B, sorry, has also come to a 1. Okay, let us see some other sums. Here comes a typical question of this chapter. See, they will give you like this: sin A is equal to 3 by 5. Okay, find tan A. Find tan A. Okay, sin A is equal to 3 by 5. Find tan A. And the other one that they are asking is cos A. Two values they are asking. So whenever you see this kind of a sum, your first job is to draw a tiny triangle, right angle triangle, just in that paper. No scales, nothing, no rulers, just a freehand diagram. And mark the angle A. This is the angle A. You don't even have to write BC and all. Here, This is the hypotenuse clearly. Formula for sine is perpendicular by hypotenuse. So this must be the perpendicular, this must be the hypotenuse. If I use Pythagoras theorem to get this, let this be x, 5 square is 3 square plus x square, which is 25, 9 and x square, which is 16, right? 25 minus 9 is x square. X is equal to 4. Okay, so if x is equal to 4, we can write it here. Now we are ready to find these values. Okay, so tan A is equal to 3 by 4 and cos A is equal to 4 by 5. Okay, so we have got all the values. Here I want to do one kind of clarification. There is too much of confusion whenever it comes to a square or a cube. Okay, now let's see. This has nothing to do with the sum. This is just a concept. Tan A is 3 by 4. Now sometimes you will get tan square A. Okay, if you get a tan square A, then it means 3 by 4 value has to be squared, which is 9 by 16. Okay. Now sometimes it gets written like this. This is nothing but this. This is this. No confusions. This is equal to this. Okay. Now don't give this 2 to the A also. This means the square is for the final value of the tan ratio. Okay. Now, if you have like this is a different thing. This and this, these two have the same meaning, but this has a different meaning. It means the angle A has been squared. Means if A is a 30 degree, supposing A is a 30 degree, then it is tan 30 degree square, means tan 900. Okay. So that is the meaning of the square on the angle. The angle gets squared. Okay, but if the square is outside the bracket, it is meant for the final ratio has to be squared. The same thing applies for cube also. Any power, it works like that. Okay. Here is a question. Cos A is equal to 0.6. Cos A, find all other trigonometric ratios. That means when they say all other, find all other trigonometric ratios, when they say this, it means nothing but, okay, all it means is that one has been given, you find the other 5. Okay, so cos A is equal to 6 by 10, make it like this, and then make it 3 by 5. See, I have reduced with a 2 because it has to come to the lowest term. Okay, then here goes your triangle. Draw the triangle, put the A, B, C. You don't put it, is fine. Okay, here. And then this is your base and here is your 10. Now find this. Make it x. 100 is equal to 36 plus x square. That is, I have used Pythagoras here. X square is a 64. X is an 8. Right? So x is an 8 using Pythagoras theorem. Okay. 10 square, 6 square and x square. 10 hypotenuse square is perpendicular square plus base square. So x is an 8. Done. So if x is an 8, now we can find all other values because all three sides are known. So we can find, first thing I'll find is ck because it is just the reciprocal. I don't have to think. That's what I do. Okay. Sin A, take it from here. Okay. That is, sin A is 8 by 10, right? Sin A is 8 by 10 and you could have put 3 by 5 also here, but since I have taken this one, this value I have written here, so I will have to reduce little bit in the final answer. Okay, so sin A is 8 by 10, but then 8 by 10 can't be my answer, so it is 4 by 5 after reducing. Then cos is done, cosec A is 5 by 4, reciprocal of this. Okay, come to tan A is 8 by 6, which is 4 by 3, 8 by 6, that is 4 by 3. Okay, and then we are left with cot A. Cot A is a 3 by 4. So we have found all the 6 ratios. There is no need to convert them to decimals. You can leave it like this. Okay. Now this is the last sum for today. Sin theta, very interesting, and this sum I am doing because there's a high probability of you all leaving this sum in the exam, but then it's so easy, so I want to do it and show it to you how easy it is. Find cos theta plus sin theta, cos theta plus sin theta in terms of P and Q. Okay, find cos theta and sin theta in terms of P and Q. See, P and Q values we will not know till the end of the sum. We need not know also. They have written clearly in terms of P and Q. Okay. So now, if sin theta, let this be theta. This is my triangle. Here's my 90 degree. So this is my hypotenuse, which is a Q, and this is the P. Okay. If this is the P, now let me find this. Let me name it as an x, and x square plus p square is equal to q square. I am using Pythagoras. Okay. So x square is q square minus p square. Okay. Please don't write 90% people will make it x is equal to q minus p. No, x is not equal to q minus p. Please don't do that. Okay. So x is just root over q square minus p square. You can't go beyond this. This is your value of this part, root over q square minus p square. You have to leave it like that. Okay. Now we are going to find cos theta and sin theta and add them. So how do we add them? First, sin theta is already given. How much is cos theta? Cos theta is this one by this one, right? So it is root over q square minus p square by q. Okay, base by hypotenuse, that is cos theta. Now I am going to add sin theta plus cos theta, that is equal to p by q plus root over q square minus p square by q. Okay, and that is p plus, this is just a fraction addition, minus p square by q. There's not much you can do after this. We can't proceed beyond this. We have to stop here, because after this, without knowing the value of q, we can't proceed with our calculations. Okay, so this is our final value of sin theta plus cos theta in terms of p and q. Okay, so how we found all three sides just in terms of p and q is shown here. Okay, we'll stop here today. These are few of the sums. Of course, there are more difficult sums. I'll pick them up in the next video, and keep practicing, I would say. And if you have liked the video, do not forget to like, share and subscribe. Do the exercises, and if you have any doubts, you can always tell me in the comment box. In the description box, you'll find the links of all the different parts of trigonometry, so that you can clear your concepts by viewing them. Thanks everybody.